In this lesson, I want to show you how to do empirical formulas. Let's start with the definition of empirical formula. The word empirical itself means experimental. So what happened was early scientists would look at the mass percents that we calculated in a previous lesson, and they would try to figure out what the ratios of the mass were. And they got close, and sooner or later they figured out that the best way to find empirical formulas was to actually do mole ratios. And so, again, the definition, the final definition of empirical formula, I'll write at the top of the page here, is the simplest whole number ratio of the elements in a compound. In other words, what we're doing is we are finding subscripts. We're pretending like we don't know what the ions are, we don't know what the elements are. We're just putting ourselves in the shoes of early chemists and going, okay, I found the identity of the elements, and now let's find the ratios of their mass, their moles, and then let's find the subscripts that way. So let's get started. In problem number 1 here, we are given some mass percent composition information, and the first thing that we want to do is that we're going to assume 100 grams of this compound. And what that'll do is cancel out all the percents that you see. So then I'm left with 49.5 grams of carbon, because 49.5% of 100 is 49.5. And then I'm left with 5.2 grams of hydrogen, 28.8 grams of nitrogen, and then 16.5 grams of oxygen. Now, our ratios need to be mole ratios, so the next thing I'm going to do is convert each one of these into moles. So using the molar masses from the periodic table, carbon is 12 grams per mole, hydrogen is 1 gram per mole, nitrogen is 14, and oxygen is 16. Alright, so I'll get the calculator out. This one's easy. But for the others, 49.5 divided by 12 is 4.125. And no, we're not really that concerned about sig figs here because we're taking ratios. In fact, the more decimal places you have here, the more accurate your final ratio will come out to be. So just get at least 2 decimal places here. I've learned over the years that that is plenty. So the next one is 2.057. And then the last one with oxygen, 16.5 divided by 16, 1.031. And that's enough. I could have stopped at 3 if I'd wanted. So now, seems like we have just a bunch of crazy numbers, but we really have found now the first subscripts for this chemical formula. It would be C 4.125, H 5.2, N 2.057, and O 1.031. Now that doesn't look like any chemical formula that I've ever seen, and nor you either, but that is the moles that we have in this sample of the compound. Now to make it empirical, we need to get the simplest whole number. Right now, those numbers are neither simplified nor are they in whole numbers. So the one that we have to do every time is to simplify the ratio. And we're going to do that very simply by going back to our moles, and we're going to divide each one of them by the smallest number. Now while I'm doing that, I'll just tell you this is not really kooky stuff. You do this in math all the time. If you have a fraction 2/4 and you're simplifying it, you're dividing by 2 to get 1/2, which is the simplified form of 2/4. And when you do that, you're really just dividing by the smallest number, 2. So this is very grounded in math. Alright, so we do this math here. We're going to get 1, obviously, at the bottom. And then for nitrogen, I'll just work my way up from the bottom since I'm already down there. Divided by 0.031. The nitrogen comes out to be 1.995. That is extremely close to 2. And so here it's okay to round to the whole number. But you have to be really close, like 1.9 something or even 2.0 you can round. Alright, moving on up to the hydrogen. 5.2 divided by 1.031 comes out to be 5.0436. Again, that's really close to 5. And then 4.125 for the carbon divided by 1.031. 4.000, so really close to 4. Now, those numbers, none of them came out to be exactly a whole number except for the oxygen. And that's okay. Because the reason it didn't is that we rounded for our molar masses, and then we rounded when we converted to moles. And so anytime we round, we'll never get perfect answers. But that's why I say if it's close enough, you can get to the whole number. Let's go back up to our formula and see how it's changed now. The formula is now C4H5N2, and then O1, and we will not write the 1. Now, these are simplified, and as I look at these, they're all whole number, so we've actually met both qualifications. So this is the empirical formula for this compound. Alright, so in that first example, we only had to simplify. We weren't required to do anything to fix the whole number part of the definition. In number 2, we are going to have to. So let's get ready for that. We're going to have to simplify and then go to the whole numbers. Another real brief difference in number 2 is that we don't have any percents this time. So I don't have to do that initial step of assuming 100 grams. I already have grams. So for this problem, I'm just going to start with my grams of iron and my grams of oxygen. And I'm going to convert those straight away to moles. So iron is 1 mole over 55.85 grams. And then oxygen is still 16. Alright, back to the calculator. 8.65 divided by 55.85. 0.155. Alright, I'm going to do the same for oxygen. And here I got 0.2325. Again, I don't care how many numbers are here, at least 2. So that's the ratio. It is not simplified. It is not whole number. So I'm going to divide by the smallest, which is 0.155. Alright, the top one's 1. That's easy. Now let's go to the calculator to simplify the other one. Divide by 0.155. This one came out to be 1.5. Now if you didn't round it to 4 decimal places like I did here, you might have got something a little bit different than 1.5, like maybe a 1.49 something or 1.50 something. That's okay, just again the rounding. So but I got exactly 1.5. So now my empirical formula could be FeO 1.5. Now that is a simplified ratio, but it's not a whole number ratio. So I'm going to fix that in this problem. My decimal is 0.5, and so using some basic math skills, I know that if I multiply 0.5 by 2, so 0.5 is 1/2, by 2, I can turn that into a whole number, and that'll be 3. But I do need to do it for everything, so multiply the iron by that as well. So the actual empirical formula for this one comes out to be Fe2O3. And we see this is iron 3 oxide. Alright, continuing on now with number 3. Let's see what we get out of sulfur and oxygen. Back to this problem, the percents show up, so I'm going to take the 100-gram assumption here. And by the way, you could pick any number here. You could pick 50 grams, you could pick 10, you could pick 2. I picked 100 grams because it's the easiest number to pick to get rid of those percents. And so 40 grams of sulfur, 60 grams of oxygen, and let's convert them both to moles. Alright, so sulfur is 32.1 grams per mole, oxygen is 16. So to the calculator, 40 divided by 32.1, 1.25, and then let's do oxygen, 63.75. So this one's going to work out pretty well. Alright, not simplified, so let's divide by the smallest to simplify it. And like I said, this one works out pretty well. This comes out to be 1 and 3, spot on. So the empirical formula for number 3 is SO3. That's not sulfite, that is a covalent compound called sulfur trioxide. There's no charge there. And then finally, number 4, we have formaldehyde. We're back to these percents here, so let's assume our 100 grams so that we can take 53.3 grams of carbon, convert it to moles. I'm going to go ahead and do that this time, 53.3. 4.442, and then we have 6. And I'm just kidding. It's like I'm really here. Alright, let's try that again. Alright. So carbon was not 53.3, carbon was 40 grams. Alright, let's do this where it makes sense now. 40 divided by 12, so 3.33 moles. Alright, and 6.7 grams of hydrogen. Hydrogen's 1 mole over 1 gram, and so that's just 6.7. And then the oxygen that I was apparently so excited to get to is 16 grams per mole. So now 53.3 divided by 16. 3.33 moles. All right. So now let's simplify this ratio. The smallest number is 3.33. It actually appeared twice. That happens from time to time. So 1, and then let's see what 6.7 is. It's 2.012012, repeating all that good stuff. So that is 2. And then this, of course, is 1. So for formaldehyde, the formula, empirical formula is not that. C, H, 2, and O. All right. Hopefully those 4 problems will get you started, but I do have just one thing to add. Only one of these first 3 problems was one where you had to go find the whole number ratio after you simplified it. You'll see more of these examples as you work practice problems. That is actually the hard part of this. Most of the time, your ratio would have like a 1.5 or a 2.5, and that's the most common fraction or decimal you get, so you multiply by 2. Sometimes you may have a ratio where the number comes out to be 0.33 or 0.30. In those cases, you want to round to the 0.33 and multiply by 3, everything by 3. Some cases, you need to round to 0.25 and multiply everything by 4. But those are rarer. You will see them on quizzes and tests. They'll pop up, and we'll have to find more examples of that when I get back and do some more in class. But for now, take this and work the other side for further practice, and I'll see you when I get back.